Alright, so we're going to talk about conditional statements. So when you have a conditional statement, it has a hypothesis and a conclusion. So you write it as if the hypothesis, then the conclusion. This little squiggle, the tilde, if you put that in front of the letter, that just means you negate it. So if your hypothesis is if I eat lunch, your negation would be if I don't eat lunch. Pretty straightforward. These are how you do the 4 types of statements that we're going to cover today. So you've got conditional, you've got converse, inverse, and contrapositive. A biconditional statement we'll get to also at the end. You can only do a biconditional if the conditional and converse are both true. Okay, so let's get into what we're doing. So number 1 and 2 here, you have a hypothesis and a conclusion. So your hypothesis is if 13x minus 5 equals, if 13x minus 5 equals negative 18, then the conclusion is x equals negative 1. There we go. That's the conditional statement. This next one, if a shape is a triangle, then the sum of the measures of interior angles is 180 degrees. Right. Hey, if you process faster than I type, feel free to speed up this video. So let's get into this scenario. I'm going to start with one that's not math related. If Benjamin watches TV is the hypothesis, then Baby Shark is on. So Benjamin watches TV is the hypothesis. Baby Shark is on is the conclusion. So if Benjamin watches TV, then Baby Shark is on. Alright, for the converse, we just flip them. So your hypothesis goes first, the blue one goes first. If Baby Shark is on, then Benjamin watches TV. Okay, to get to the inverse, you take the original one and then you negate both statements. So if Benjamin doesn't watch TV, then Baby Shark is not on. So only difference between this one, only difference between the inverse and the conditional is you negate both statements. Then if Baby Shark is not on, then Benjamin doesn't watch TV. There you go. We'll get to the biconditional later. So here's a math related one. Works the same if quadrilateral ABCD is a rectangle, then the sum of the angle measures is 360 degrees. For the converse, we flip it. If the sum of the angle measures is 360 degrees, then quadrilateral ABCD is a rectangle. Alright, I think you get the idea. So if you get the idea, you can fast forward a little bit. I would suggest just using the speed up function. If quadrilateral, you know what I'm going to do? I'm going to copy this. If quadrilateral ABCD is not a rectangle, then sum of the angle measures is not 360 degrees. See how easy that is? And then for this one, I'm going to copy and paste it. Is not 360 degrees, then quadrilateral ABCD is not a rectangle. Oh, the other thing fell off my screen. So I'm going to try to keep this one. Yeah, so just one note about this, when you negate a statement, so let's look at this one. The hypothesis is the light is red. So that's your P. And then your other one is going to be your conclusion. Your conclusion is don't go. So this is the contrapositive. No, this is the inverse. So we're negating both of these. If the light is not red, then go. So you'll note this blue one, I negated it, but because it's already a negative, you make it a positive. So just be mindful of that. Last thing to show you with biconditionals. Let's talk about this here. Let's change my text color. If Benjamin watches TV, then Baby Shark is on. This is true. If Baby Shark is on, then Benjamin watches TV. This is also true. So remember we talked about biconditional statements. If the conditional and its converse are true, you can write them as a single biconditional statement. So the way I do that for this biconditional statement, I would write Benjamin watches TV if and only if Baby Shark is on. So let's look at this one. If quadrilateral is a rectangle, angle is measured 360 degrees. Yes, this is true. If the sum of the angle measures is 360 degrees, then quadrilateral ABCD is a rectangle. This one is not true. False. The reason why, right here. Here's a rectangle. These are all, okay, so if quadrilateral ABCD is a rectangle, this one, then the sum of the angles is 360. Yeah, all four of these angles add up 360. If you flip it, all four of these shapes, the angle measures add up to 360. But these two are not rectangles, so that proves this one false. So that was a counterexample. That was up here too, right? No, it was not. That's a different lesson. So for this one, for this biconditional, this one does not have a biconditional statement because they have to both be true. Alright, that's it.